asked all of you.
Yeah, the 5 programs, right? I'm just confirming.
Sorry.
The 5 programs
Hello.
which you gave, right? With the indexing or and all.
Yes.
Yeah, I've done
Yes. Yes.
most of.
Yes.
Yeah, just 1 or 2 of them are left.
Okay. 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 Please continue. And if you get any questions, feel free to ask. All right. So
Okay.
yeah, can you give me the host privilege, sir, so that I can share my screen? Hello, sir. Can you give me the host privilege? Yeah. Okay, I got it. Thank you. I'll just share my screen. Okay. Can you see the screen? See that? Hello.
Yes, sir.
Okay. Okay. You can share. You can see the screen now. All right. So yeah, today I was going to talk about functions and packages. All right. So I was supposed to talk about the object oriented programming also, but the thing is that functions and packages itself is a huge topic to cover. All right. So I'm afraid I may or may not be able to cover it in one class only because there are lots of things to understand. All right, but let's go into it. So sorry for that. I was supposed to put this one over there. Let me just put it right now. Yeah, directly copy pasted. That is why it's showing like that. Just hold on. All right. Now, today we are going to talk about functions in Python and how to use them. And we'll also introduce the packages in Python. Now, functions and packages, they somewhat look like, the name someone might look like similar, but there is a very good distinction between them. And packages actually contains some scripts which in turn contains the functions. Okay, inside the packages there are some scripts, and inside those scripts there are some functions, or in some cases some modules. All right, so now first we'll talk about Python functions, and then we'll move on to the packages. Okay, and so talking about functions, function is a block of code which only runs when it is called. So it's a very simple definition of function. Actually, there is nothing much complicated in here. It's a block of code. You give some input and it gets an output. But there is a very interesting difference between functions and the scripts that we have been writing till now. So in function, the code becomes more modular. Okay, code becomes more modular. It becomes more and more organized. It becomes organized, and you can easily call that particular set of code whenever you need in the later part of your code. That means, suppose there is a task that you need to repeat, but after an interval, not exactly on that particular time. Like you don't need to repeat for a particular time, like for n times or for n+1 times. You don't need to invoke that particular piece of code, but you might need to invoke that after the first call. You might need to invoke that after some time. For example, like suppose you're writing a code in Python. You need to add suppose two numbers, and then again after some time again you need to add two more numbers. So that addition task has been carried out over and over again. Not over and over again, but it is carried out after some time, after an interval of time, right? So in those cases, if we want to if you want to write the code in such a way that like you can write all the codes over and over again, but it will take some time, and the code will not look good, because there will be lots the same lines of code repeating over and over again, and that actually decreases the code reuse property. So that is why we need a function, so that our code looks more properly organized. It becomes more modular, and you can reuse it over and over again whenever it is required. You can pass the data, they are known as parameters or arguments also, into a function. Okay, a function can return a data as a result. Whenever you invoke a function, most of the time function is supposed to return something. What it will return? It will return a data from where it was called. Okay, from where it was called. Now, the simple definition would be it's a block of code which only runs when it is called. You can create a function and you can leave it there, and it will only be executed when it is called. And you will have to give some, not exactly you will have to, but you should give some parameters or arguments into a function. It will return some data as a result. And function provides better modularity for your application and a high degree of code reusing. These are the two important properties which you can use, for which you need a function. Yes, Siddharth, please.
Like we write statements in Python. So what are the main, I didn't understand what is the necessity of using functions? And as you said, you should give some data, you should give some parameters. What is the necessity to do that?
Yeah, so see, I already gave you an example like that. So see, there are two basic reasons here I have mentioned: modularity and code reusing. Okay, for those two, but let me draw an example in OneNote. That way you might understand it better. All right, let me just put up the OneNote here. Okay, I'll delete this one and I'll put another one. Okay, now so I will be drawing. Yeah, sure. So suppose you are writing a set of code. All right, you are writing a line of code and you have written some. Hello, am I audible?
Yeah. Yeah,
my connection unstable. So you are writing a code, and after some interval, you had to write the same code again. Okay, the same set of code to be written again. So like this. Now see here, these are lines of code considered. Okay, there are some codes written here, and inside in whole scenario, these are some of the lines of code which are getting
your voice is
repeated
cutting a
in
lot.
yeah. Hello, can you hear me now? Hello.
Yeah, we can hear you.
Okay, sure. So in some part, in some cases, what happens is that you might want to reuse your code after some time. Okay, not exactly all together. You might want to reuse the code after some time. If you had to reuse the code right here, you could have used the loop and you could have run the loop for 2 times, right? You can just run a loop for 2 times. If it is a continuous interval, if it is a continuous time, then you can use a loop. This is not continuous. This is something which we call as discrete. Okay, after some time you are using the same set of codes. So what you do is you can put all these same sets of same lines of code together in a function. Okay, and what you can do, that function will produce only one line. That function will require only one line of code to call that particular function. Okay, so you write, instead of writing all these 4 or 5 lines of code, you wrote one line of code that calls that particular function. Again, over here you wrote the same line of code with the different parameters or arguments, and it again called the function. So instead of writing the whole thing over and over again, you simplified it using a function which actually took all those codes away from your program. That will help in two cases. One, modularity. Modularity means how compact your code is, how distinct your code is. Okay, so these sets of code are supposed to do a specific task, and when that specific task is written in a function, other programmers will also find it easy to understand. Other programmers will also find it easy to understand because your function name, your function will, the lines of code over there will tell the other programmers what is the task. And always remember, a function will do only one task. It should be designed in such a way that it can do only one task. All right, so first one was modularity, second one was code reuse. So you are writing the same code in this one function only, and then you are reusing the code over and over again for as many times as you want. So that is what code reuse is, and that is the purpose of function. If you want to make your code more distinct, better, if you want to write a code in your in a better version, it's better that you use a function. You don't need to. Okay, sometimes you don't need to use a function, but it's better if you use it, because as a programmer you will have that clarity. You yourself will have that clarity, because think about it in simple way. You have written this program, you saved it, you forgot about it, you moved on to write some other program. So after 6 or 8 months, you again revisited this program. Which one would look better? There's all these lines of code repeating over and over again, or all these lines of code with some functions that actually compacts code in one place, and you can see it from there only. So that way it looks far better than the writing the lines of code over and over again. You don't need to, but it's highly advisable that you use functions. Okay, it's highly advisable that you use functions. Till now we haven't. From right now, we'll try to use as much as we can. All right. Did you understand? Hello? Hello?
Yes, sir.
Yes, sir.
So basically, we just instead of copying the whole code later in the program, we just we can write a function and reuse it there.
Not quite. Like, you can copy the whole and use it in later part, but then your code will look messy. See, I'll tell you what happens actually. Okay, I'm going to dive a little bit deeper. Okay. Hello? Hello?
Yes, sir.
Okay, my internet connection is unstable. It is showing me sometimes. All right. So I'm going a little bit deeper in computer science. I hope you'll understand. If you don't, let me know. All right. So we measure how beautifully a program is working, how efficiently, the word is efficiently, how efficiently the program is working by checking the lines of code into it. Okay, what are the lines of code that we need, how many lines of code that we need to complete this particular task, complete this particular work. When you copy and paste the code, same code over and over again in different places, the lines of code increases. You can decrease the same by writing the same lines of code in one place and referring to that particular place by writing only one line of code in your per program. And that particular place where you write the program and you refer to it over and over again as you require with different parameters is called the function. Is it okay now?
Yes, sir.
Okay, so this is technical. Okay, this is completely technical thing to understand. We don't only measure the lines of code. We also see how many loops are there, how many variables are there. All these things we measure, but that is not for now. That will be in your if you pursue computer science later stage, then you will kind of get that. But anyways, what I'm trying to say here is that you use if you use functions to create your code, to organize your code. It's a good way of organizing as well, to organize your code. Then in later stage also you will find it easier for you to understand after you come back after some time. Okay, so this is the idea. This diagram shows us what is the function, how the function works, I guess. Sorry for that. Okay, what is happening? Okay, so here you give inputs, arguments you give. They're also called as parameters. The function carries out some task and it gives an output. Okay, so simply if the question arises, what is function? You should answer like this. Function is a block of code that is designed to do a specific task. So this is the actual definition of function. Okay, I'm writing this here. Function is a block of code designed to a specific. This is the definition of function. Please write it down somewhere, or please copy it down somewhere from the chat. Anyways, moving on. Types of functions. So there are two different types of functions that we find. The first one is built-in function, and the second one is user-defined function. So in built-in functions, they are created in Python. Okay, built-in functions are the functions that are created in Python. That means in the Python library, you will automatically find all these built-in functions such as print or type, etc. Second one is user-defined function. So in case of user-defined functions, you get to define your own functions. That means when a programmer creates their own functions, those functions will be called as user-defined functions. The basic difference is that in case of built-in functions, you will find them unchangeable. You'll find them unchangeable. You cannot make any change in the built-in functions. However, you can make change in the user-defined functions. Why? Because they will be defined by you only. Built-in function, you don't get to access the code. You can access the code, you can change it if you want, but the specificity of the built-in function might get lost. So that is the idea here. There are two types of function, built-in and user-defined function. Next, declaring a function. Now this is where it gets technical. So function blocks begin with the keyword def, def, followed by function name and parenthesis. So parenthesis, you can see that, and inside that parenthesis, you can put some parameters. Okay, you can, or you may put, or you may not put the parameters as per the requirements. However, if you don't need them, you just put the parenthesis, but you have to put the parenthesis here. So how you write def, then you write function name, then you put the parenthesis, and if the parameters are required, then you put the parameters inside that parenthesis. Okay. And input parameters, any input parameters or arguments should be placed within the parenthesis. And those parameters can be defined also inside the parenthesis. That means you can put some values also. Explicitly, you can put some values also, but that is not necessarily required, because when we call a function, we'll definitely use those parameters. The first statement of a function can be an optional statement. Okay, the first statement of a function can be an optional statement, that is function that is written inside the double quotation. That double quotation statement is optional. You may or may not use it. I don't. I just go to write all the things that are required to define the function, and then leave it there. Okay. So what you can do is you can use or may not use that docstring function, and you can use the docstring function to tell about some what the function does. What is the purpose of that particular function? The code block within every function starts with a colon. That means after writing the name of the function, you need to put a colon, and then only you can move forward with the code block. And they have to be properly indented, because indentation is the only thing that defines which code lies within which code in case of Python. In case of other languages, we get some curly braces and everything, but in this case, we only get the indentation, and we use that indentation to our best. So indentation is required, and you will get that indentation when you put that colon. If you forget to put that colon, you will not get the indentation. You have to put that colon. After that, you press enter any text editor that you want, like whether it is in idle, whether it is in PyCharm, whether it is in Jupyter Notebook, whatever you use, you have to put that colon, then only you will get the indentation. Okay. The statement return exits a function. Okay, it exits a function, and it optionally passing back the expression to the caller. So there are two things that you should know in terms of function. One is this defining a function, and the second one is calling a function. How to call a function, we'll talk in the next slide. But now understand this, when you see this return statement, you have to realize that this return statement will definitely return something. But where it will return? It will return that value or whatever that is to the place from where it was called. Okay. It will return that particular value. It will return that particular result of the expression or whatever that is to the caller, to the place from where it was called. Okay. A return statement with no argument is same as return none. Yes, Siddharth.
And what exactly are parameters in Python? I can't understand.
Yeah, sure. I'll show you. I thought that that question might come. Great. Let's delete this. I don't need this. Just try to delete this also. Okay. Let's just hold on. So I told you that you write some code. Okay. And above that, suppose you have defined a function. Okay, you have defined a function. This is D, by the way. Sorry for writing this like that. I'm really bad at writing. Okay. This is def def, and this is the function, suppose. All right. This is the function. Now, whatever you give inside here, they will be called as parameters. They will be called as parameters. P-A-R-A-M. In some cases, it might written as param. That means parameters. So I told you there are two things for you to understand here. One is parameter, one is function definition, and the second one is function call. So function call. Okay. When function call happens, what will happen is that from this point, the function will be called and the control, the Python compiler, Python interpreter will directly move into this function part. Okay. And in that call, you will give some values. Okay. You will give some values. Suppose some values are given here. Suppose this is 5, this is 6, all these things are given here. Okay. And these values will be sent directly to the parameters. So the parameters are supposed to receive, it is supposed to receive some values when the function is called. Two things: definition, what the function will do, that is the definition of the function, and call, when the function will do that particular task, that is the call here. And inside that call, you need to give the parameters. If you don't give any parameters inside here, then you don't need to give any values. But if you give a parameter, you have to give some values in the call. And those parameters will be used inside this function definition. Inside this function definition, those parameters will be used, and those parameters will be used to define or find out the results. Okay. And after that, there will be a return statement. There will be a return statement. And that return statement, when the interpreter faces that return statement, what will happen? It will directly come back to the place from where it was called. Okay. And whatever the value there is, it will bring it with it. Okay. Suppose there is a value that has been returned, say A, that value will be brought back to the called part. Okay. And that value will most probably be the result that we are looking at. So this is the main idea about function. This is the main idea about working of a function. First you need to write the definition of a function. If you you can write it at the later stage also, but whenever you write the definition, make sure you write this keyword def, you give the function a name, and you give some parameters if required. If it is not required, then it's okay. And second part is you have to call the function wherever the code requires it. Wherever the code requires that this task needs to be done, you put the call. You call the function, automatically the interpreter will move on to this definition, and based on that, it will execute and return some values to the called part, to the place where it was called. Okay. And of course, there will have to be someone who can receive that value. Okay. So this is the most basic idea about function. Now, do you understand?
So, like, can you give an example of a parameter? Like you said, if you have a parameter, we'll have to write, like, for example, 5, 6 there. We'll have to give a value. So, can you give an example of a parameter?
Do you want me to write code or like in the diagram itself? Okay, I'll give you example in the diagram itself. All right. Hello?
A code would be better.
Code would be better. Great. Works for me. Let me just open Anaconda. Just open Anaconda. And meanwhile, let me just go through the calling part quickly. So if you call a function, so here you can also understand what is the parameter here. So to call a function, all you need to do is you need to use the name of the particular function and you need to follow them by the parentheses. And whatever the arguments here, the arguments will be given inside the parentheses only. So as you can see in this example, def division is the name of the function. The function has been defined here and value has been returned from the particular function, and the parameters are first and second. These parameters are nothing but these are actually variables. Simply speaking, they are variables. We are giving a fancy name to distinct them as a part of a function. Okay, parameters are nothing but variables. It is first and second, both are variables, and they are supposed to get some values. So when you call the function, what you need to do first, you need to write the name of the function. The name of the function was division here. So the name of the function is division. And then what you do, you write the values. Whatever you want to divide, you write the values. So 10 and 2 has been given. Now, here what will happen? The value 10 will go to first and value 2 will go to second. Okay. How the parameters will receive the values? In the order that has been given to it. The same order has to be maintained. 10 will not go to the second, 2 will not go to the first. 10 will always go to the first and 2 will always go to the second. And after that, what will happen? The value of first is 10 now. The value of second is 2 now. 10 by 2 value has been returned as 5, and that 5 value will be returned to the output. And at the print statement, the output will be printed, that is 5 will be printed. Do you understand it now? Let me take an example here. Then you will understand even better.
So now I understood. I was just confused. Like, now I understand. Like, it seems.
By mistake, I opened Spotify instead of Anaconda. Sorry. Yes, please. Hello.
It seems to me as if it's a calculator. Now I understand what exactly is a function. Like, we're defining variables. That's it. I was just confused with the words, like arguments or the parameters.
Yeah. These things confuse actually. Yeah, that's true. Okay. Anyways, I'll take this example so that you understand it better. Let me just boot up the Anaconda navigator. It is still initializing. It is taking some time, but it's fine. Okay. Anyways, so I hope it has loaded. Yeah, it's been loaded. Let me just launch the Jupyter Notebook. Okay. Do I have something right here? Hopefully so. Yeah, class demo. Is that all right? So what I can do is, let me just okay. Let me just write this code here. It's a function demo, right? Just delete that. Setting up the environment here. All right. So, yeah. What we're going to do is we're going to define a function. Okay. Add A, comma, B. So this is the definition of a function. I'm starting to define a function called add that will add two numbers and return the output. Okay. So output Okay, don't worry, I don't need to write the output. C equals to A plus B and return C. Okay. Now here what I'm going to do is I'm going to call. Okay. So output equals to add A comma B. I'm going to run this one. I'm going to run this one also. And in the third cell, I'll write print. So in this A comma B values, I'm going to give some values here. Okay, these values are called as, this one is called as parameters. This one is called as parameters. And here it will be called as arguments. But ultimately they are variables and values. Okay, they are simply variables and values. And whenever I run it and when I print it, see, this is the simplest concept of function. All right, this is the simplest concept about function, that what will happen, this 10 plus 5 will move, this 10 will go to A, the 5 will go to B, and they will print the output. Let's put it as A minus B. Then what will happen? Then we will get the output as 5. Okay, but if I write 5 here and 10 here, then we get the output as minus 5. So this is what I'm trying to tell you. The first argument will go to the first parameter. The second argument will go to the second parameter. That is what, that is all you need to remember right now. That is all you need to remember, and I hope you'll remember it. Okay. So leave page. I'll close this one also. Sure. I'll close the Anaconda Navigator because it is taking a lot of RAM from my system. I will terminate it, of course. Just hold on a second. Yeah. Of course, yeah. So this is about calling a function. Is there any questions about it? I hope not.
No, sir, not for me.
No, sir.
Okay, great. So, but what about arguments here? Argument is interesting here. All right. Let's see arguments now. So information can be passed into the functions as arguments. Okay, and arguments are defined inside the function name inside the after the function name inside the parenthesis. You can add as many arguments as you want, but separate them with a comma. So what we do is most of the time we use argument, the word argument and the parameter interchangeably. Okay, sometimes we call the parameters as arguments and arguments as parameter, and vice versa. It happens. However, there's a small difference here. Okay, there's a small difference here. Here is the difference right here. Parameter is a variable listed inside a parenthesis in the function definition. Argument is the value that has been sent. Okay. The reason that I have added this slide is so that you can understand, so that you can remember the difference between parameters and arguments. I know this might be a little bit tricky concept for you, but just bear with me. Try to understand that when you call upon a function, you give arguments. When you define a function, you give parameters. So that is the basic difference. All right. So up to this point, is it clear? Do you think you can define your own functions? I'm asking both of you. Do you think you guys can define your own function?
Yeah.
Yes, sir.
Okay. So what I want you to do is try to write a function. Hello?
Yeah.
Okay. Try to write a function. Try to write, okay. Try to write four functions here, like functions 1 add, 2 subtract, 3 multiply, 4 divide. Okay, then you can do it in your Jupyter notebook or Python, wherever you want. Okay, then what you do, then write a program that will take values from the user and give outputs from those functions based on the call. Based on the call, based on the call, they will give you the results to the outputs. Okay. So what I want you to do is write these 4 functions, obviously, and then write a program. At the end part of the whole code, write a program that will take inputs, 2 inputs, obviously, A and B, take them and send them to the functions, and they will do whatever they want. There's add will do addition, subtract will do subtraction, multiply will do multiplication, and divide will do division. And based on that, all the 4 functions will return some values, and those return values will be displayed. This is a very simple function. Okay, try to write it. I'm not going to complicate now, because you are just learning about functions. So try to write this, and in the later stage we will write more, even a little bit more complicated functions. Okay. So
we just
did
have
you
to write,
understand this?
we have to write 4 different functions here, right?
No, you don't need to write 4 different scripts or anything. You don't need to write 4 different notebooks. You need to write one notebook. Over inside that there will be 4 different functions. Okay. In 4 cells, there will be 4 different functions. In the 5th cell, you are going to write the last part of the program where the functions will be called. Is it clear to you now?
I'm just confused. If you're saying we have to write, like you wrote one for add and then subtract, do we have to write different functions?
Yeah, you have to write different functions in different cells. That means there will be 4 functions: def add, def sub, def mul, def divide. There'll be 4 different functions. You have to write all the definitions, all the parameters, and all the things. Is it clear? Is it okay for you? If you can do only 2 of them also, then also okay. If you can do only 2 of them also, that is also good enough. Okay, that is also good. Okay, just try to write at least 2 of them. All right. One of them you may not get the grasp, but 2 or 3 of them you will get the grasp how to write the functions. And in the later stage, you will automatically understand which part should be in the function and which part should not be in the function. All right. Anyways, this is the difference between parameters and arguments. Now, talking about lambda functions. So this is a very interesting concept, and we'll finish off with lambda functions today. Tomorrow we'll discuss about packages. All right. You need some time to digest all these things, and I can understand that. So lambda function is simply a small anonymous function. Usually a lambda function you can write using only 1 line of code. Okay. And that lambda function can take any number of arguments, but it will only have 1 expression. This is the beauty of lambda function. It is an anonymous function. It does not need to have any name. Okay. It does not have any name. It only has an argument. It only has an argument and 1 expression. Only 1 expression. That argument or that number of arguments will be given to the function, to the values, and it will automatically return those multiplied values or whatever the expression is, the result of the expression, like this. So this is the idea here. It can take any number of arguments, but it will only have 1 expression, first of all. Secondly, it will consider the whole thing as an anonymous function, which takes a value, sends it to the expression, and the results will be sent. And only 1 expression is allowed here. So the power of lambda is better shown when you use them as an anonymous function inside another function. So function inside function, it is like the nested function. Okay, so the way of writing the lambda function is lambda arguments colon expression. As you need to write the keyword lambda, then you need to give the argument, and you give a colon, and then you write the expression. Why we need it? Well, simply speaking, you might need it to write. You can actually reduce. Hello. Hello.
Yeah, your voice is cut.
Sorry. So why we need lambda functions? Okay. The reason that we need lambda function is that lambda function actually helps us to reduce lines of code. Okay. There are some programs, there will be some programs where you need to use a lambda function inside a list, and that lambda function will give you the results one by one. For that, you can use a loop. So use a loop inside a list, and inside that loop there might be a lambda function. So that kind of situations, if you go and write the code in all the things all together, then it will take 3 or 4 lines of code. Okay, so that is what I'm trying to say here, is that lambda function actually helps us to reduce the number of lines of code very easily, and it will also give you a better result when you put the function all together. So let me take this example. Just wait a second.
Can I ask you
Say
something?
x equals to, yes, please.
Yeah, so you're saying it can have multiple arguments, but it only has one expression. What do
Yeah.
you mean by that? Only one expression?
That means after the colon, you can only write one expression. Did you understand what I said?
Yeah, I understood what you said, but like, can there be multiple arguments in the normal function?
Yeah, you can put as many number of arguments as you want. Hello?
Yeah.
Did you understand what I said now?
Yeah, and only one expression after the colon. You have written a plus b. So does that count as one?
Yeah, that does count as one expression. Expression, not value, not argument. Expression. Expression means there will be operator and there will be operand. You remember the concept of operator and operand?
Yeah.
Yeah. So this is operator, and this is this is operand, and this is operator, right? So that operator and operand altogether constitute an expression. And here, as you can see, I have defined a lambda function called x, which contains 2 arguments, a comma b, and contains one expression, a plus b. If you want to write like this, def x, like you can write like this also, right? A comma b, you give a colon, you start writing the function, c equals to a plus b, then return c. You can write like this also, isn't it? Normal function concept. Lambda function C, it takes 3 lines of code, and in the lambda function you only define 1 line of code and it will work the same. So this is the power of lambda function. It actually reduces the lines of code, and that is the purpose of lambda function as well. It is used to reduce the lines of code. Is it okay? Is it clear now? Do you understand why we need the lambda function? Hello?
Yeah, sir, I understood that.
Okay, great. And just remember, lambda function will have n number of arguments, but lambda function will have only one expression. That means one expression for per lambda function only. At one lambda function, one expression. But it can have n number of arguments. If you want to give like one more argument like c, d, and give plus c, plus d, plus c, like that, you can go for it. It's fine. Okay, so try to define some lambda functions as well. If possible, try to define some lambda functions as well. All right. So I'm going to finish it today for this.
Sir, I have written the code.
Which one? Which one you have written?
That addition, subtraction, multiplication, and the division one.
Can you paste it here?
Yes, sir. I will post it in the.
Please paste it in the chat. I will just okay. So function, you have any question? Okay. Okay, see, you can again reduce the number of codes here. Hello, Abir, can you hear me?
Yes, sir.
Yeah, you can again reduce the number of codes here. All right. So
Yes.
you are giving here. Okay, great. All right, let me just see. You can write see, you are repeating these two statements over and over again, isn't it? Hello, Abir, can you hear me?
Yes, I saw now that I'm.
You are writing these two lines over and over again. What you can do is you can put these two lines in one place and you can just continue. Okay, you can just write here. You can just write here and you can continue. And you have created a menu driven program, which is very nice. That means you are very nicely progressing and it is very good. Okay, so try to.
Yes, there's that 1, 2, 3, 4.
Yeah, menu driven program, that is called as menu driven program, because you are giving a menu here. Right here you are giving a menu. Press 1 for addition, press 2 for
Yes.
okay, so this is very good. I like it a lot. Just put these two lines after this. Okay, after this,
Okay,
after
sir.
IMP input enter your choice, after this just put these two lines and call them up. Is it clear for you? Hello?
Yes, sir. It is
Okay.
clear.
Okay, great. And when you put A and B outside, you have to give the values here: A comma B, A comma B, A comma B, and A comma B right here inside the name of the function, inside the function calls. Okay, write the function.
Okay, sir.
Put the values inside here. You save it. You save the code, this one, and you make a copy of it and you edit on that. Okay. I think I'm sure this code will work. I think it will work. Okay, and try it out.
Okay, sir.
All right. So any more questions, Siddharth? Yes, Siddharth, please.
So I don't have any question related to this, but I wanted to ask from how many years have you been working in this field, like Python and all?
Python and all.
Yeah, like NLP, Python, I mean the whole computer science field.
I have been in computer science field since 2010. Okay. I have been working in NLP since 2015, and I've been working with NLP with Python since 2016. Yes. Why? Why did you ask?
No, I was just I was thinking for like a career, thinking about the future and all. So I was thinking about if there is any possibility of combining astrophysics or astrobiology with computer vision.
Okay.
Is that a good option?
Yes, of course. Of course, combining, you don't need to combine. Actually, combination has already happened. You want to do interdisciplinary. This is called interdisciplinary. Okay, you are merging two disciplines to get the best out of both of it. Okay, let me just stop sharing. I think sir can also stop recording. I'm going to talk about careers now, I guess.
Hello, Shiva sir. Actually,
yes.
Sorry to interrupt. Actually, sorry for interruption. Actually, from 7 o'clock there is some other class. So, can you take tomorrow extra? I know today it was 5 minutes less.
Okay.
Can you in the class today? If you don't mind, in 1 and 2 minutes.
Just give me 1 minute. I will talk.
Yeah. Please, in 1 minute, please. Thank you very much.
Okay. So what you're trying to do is a very good idea, actually very interesting thing to do, and I think you can do it. Okay, just you can, for starters, you can just look at how nowadays astrophysics is working, and you will find that there is a very good computer application to it. All right. Hello, Siddharth, can you hear me? Yeah. So using that, you can easily work on astrophysics and everything, and you will